Hello and welcome back to AP Pre-Calculus. Today's lesson is 2.14, Logarithmic Function Context and Data Modeling. All right, so the graph above there is showing the average salary for church pastors across the U.S., and it's saying that as the congregation size increases, the salary increases. But you can see that it does not increase in a linear fashion. It is not exponential either, because at some point, at a certain point, we're not going up on the y-axis. The salary is not increasing as much as the church gets bigger. All right, this is a logarithmic function. Okay, a lot of real world scenarios have exponential and logarithmic modeling that could help us to estimate different things, and that's what we're going to do in this lesson. Okay, let's pay close attention to this box up here, the logarithmic function models. We have to get these down, guys. Let's read this sentence together. For a given set of data, if the input values appear to change proportionally over equal length output values. Now that's different than what we were looking at before. Before we wanted the input to be the same, and we were looking at the outputs to see if it was linear or quadratic or cubic. But this time, the input values will change proportionally. And remember, that means by multiplying, okay? Then a logarithmic model is appropriate, okay? So we got to get that down. So if the x's are being multiplied over and over again and the y's stay the same distance apart, then a logarithmic model is probably going to be appropriate. All right, the second sentence. A logarithmic function model has the form of y equals a plus b ln x, or you could use y equals a plus b log x, where a and b are constants and b cannot be 0. All right, let's go to example 1. Really pay close attention to example 1 here, because this shows up in the free response quite a bit, okay? So they're giving us a table. Right? We have a couple of inputs, we have a couple of outputs, and it says selected values of the logarithmic function. So they are telling us that this is a logarithmic function. We don't have to see if it is, okay? Are given in the table above, where L of x is equal to a plus b ln x. So they're telling us that want us to use natural logs, okay? So we're going to use the given data to write two equations that can be used to find the values for the constants a and b in the expression for the function, okay? So the first time I saw one of these when I was getting ready to teach this class, this one got me, and I didn't realize how easy it actually was. So I have an x and a y, well, basically a y, and over here I have an x and a y. All I have to do is substitute those numbers in twice, once with the 2 and the 3, once with the 5 and the 7, and I've completed what they wanted us to do. So the first one would look like this. 3 equals a plus b ln of 2. So there's 1, and the second one would be 7 equals a plus b ln of 5. And that completes what they wanted us to do in A. That would get us the point, okay? So it's not a hard concept. It was just weirdly worded, and so that's what you need to do. So for B, they're wanting us to actually find these values of A and B. And what we have just done is we've made two equations, and we still have two unknowns. And we've done this, we just did them with x's and y's back in algebra 2. All right, so let's rewrite these. So I got 7 equals A plus B ln 5. 3 equals a plus b ln 2. And I want to add these together and make something go away. I don't like us thinking of this as subtraction because we're not the best at subtraction. So what we should do is distribute a negative to all of these guys, so when I add them together, the a's will go away. And I end up getting this. 4 equals, I can't combine those aren't like terms, so I'm just going to write it out. ln 5 minus b ln 2. And now I can factor out that b, right? That leaves me ln of 5 minus ln of 2 and I can divide by that. So B is going to be equal to 4 divided by ln 5 minus ln 2. So once you put it in your calculator, it should look like that. And we're going to round that to 4 decimal places, but we're not going to use that rounded version to find A. So don't write down your answer for B yet. Write A equals, and you can choose either one of these equations. I used the top one. I took the 3 and I subtracted B ln of 2. And this, we can do this much easier just using our calculator. If we do 3 minus, and then we go highlight that fraction that we just put in and hit enter, it'll rewrite the fraction on our calculator, and then put ln 2 after it. I'll show you what it looks like. Okay, see what it looks like right here? I did 3 minus, and then I highlighted that fraction up there, hit enter, and it wrote it down, and I just put ln 2. So that's the same thing as 3 minus b ln 2, and there's my A, okay? And now we can write our answers rounded to the 4th decimal. Example 2. The table above gives data from the graph at the beginning of the notes related to church size and average salaries for pastors in the United States. We're going to use the regression capabilities of our TI-84 calculator to find the logarithmic function model for the data above in the form S of P equals A plus B ln P, where P represents the church size and S is the average salary in thousands. Okay, so now what we have to do is make a couple of lists. So go to Stat and Edit and fill in list 1 as your church size and list 2 as your average salary. It should look like this. And then go back to Stat down to number 9. That's your linear regression model. It should look like this. Then the screen should look like this, and we want to go down to where we can store our regression model, and we want to hit alpha trace, and then it should look like this. Just go ahead and hit enter a couple of times, and it'll calculate, and it should give you a screen that looks like this with your A and your B. And with this last screen, we'll be able to write out our formula. So let's do that. And there's our formula for the linear regression model. So in part B, they want us to predict the annual salary for the pastor whose church size is 500 people. So you could take the formula that we just wrote down and put 500 in there, but there's an easier way to do it because we did store that equation in Y1. If we just hit alpha trace again, it'll say Y1 and start parentheses, and in that parentheses, just put 500. It should look like this. So we could write our answer like this. The function evaluated at 500 is equal to 94.3295. And that's in thousands, so that'd be $94,329.50. But this is good right here. All right, example 3 is kind of like example 2. They're wanting us to do the same 2 things, write 2 equations, and then solve for A and B. So let's go ahead and look at this one. So we are talking about the sound intensity level beta in decibels of a sound having an intensity I in watts per meters squared. All right, and the function is beta of I is equal to A plus B times log of I, which means the I, the intensity, the watts, is my input. That's my X value. And then beta is the Y value. That's the output, okay? So it's saying here that if my intensity, my I, is 1 times 10 to the negative 5th, is going to correspond with 70 decibels. So I can definitely write a formula for that. The decibels is the B, so I put 70, then A plus B. I should have said beta, not B. And then log the intensity I, in this case, is 1 times 10 to the negative 5th. Okay? By the way, we could have just put 10 to the negative 5th there because 1 times 10 to the negative 5th is 10 to the negative 5th. And the second one says a loud concert has an intensity of 1, and it corresponds to 120 decibels. So what comes first? Well, decibels come first. So I'm going to put 120 equals A plus B log of the intensity, which in this case is 1. Okay? So we could definitely solve this one the exact same way that we did the other one, But this could be a question that said, hey, we don't get to use our calculators on this, and they're expecting you to know how to work this out. This log has a base. What is the base of log? It's base 10. So this one right here is saying 10. Remember, logarithms are another expression of an exponent. It's the exponent that will turn that base into that number. So you have to ask yourself, 10 to what power will make 1? And we know that that's 0. So I know that if this is log is 0 and 0 times b is 0, I'm left with a. I know that a equals 120. So now I just need to find b. And I can come over here and do 70 equals 120 plus b times log of 10 to the negative fifth. And by the way, 10 to what power would make 10 to the negative fifth? Well, the power would have to be negative 5. So really, I know that this is 70 equals 120 minus 5b. So then I could subtract 120, and that's going to give me negative 50. Divide by negative 5, and I get b equals 10. So there we have our a and our b. All right, let's finish up this lesson with C here. It says, the human eardrum can burst when a sound reaches an intensity level of 1 times 10 to the fourth watts per meter squared. According to the model found above, what is the predicted number of decibels? So I'm looking for the B part, right? So I'm looking for this part. And I can put my 120 in there plus 10 log of I. So there's my formula. And since I want to do 1 times 10 to the fourth, I can put all that in here. I'm just going to put 10 to the fourth because it's the same thing. And what happens to these two guys? That just becomes a 4, right? Because these things will, 10 to what power is 10 to the fourth? It'd be 4. So this ends up being 120 plus 40, or 160 decibels.